The Work of Groundwater
by Nick, Stefan, and Chris.
Geography 12, 12, 12, 12, 12, 12.
Groundwater is the water held underground in porous rock. It is responsible for a large amount of our drinking water and also greatly contributes to irrigation on farms. Groundwater can be found in the smallest spots underground, even under our school and many of our homes. It is held in underground porous rocks and soil that are fully saturated, meaning they cannot hold any more water. While those of us who live in more mountainous regions with glaciers can rely on water from the mountains, groundwater is the primary water source in drier areas. It is used for clean drinking water and also for irrigations on farms. Groundwater is an integral part of the hydraulic system, contributing to lakes, streams, wetlands, and surrounding ecosystems. Groundwater is heavily used in the world, so much so that we are taking out more groundwater than there is going in. This has led to sinkages, where the ground is getting lower as years go on, as seen in the photo above, where the different years mark where the ground was at that time.
Hot water underground dissolves and carries away minerals in solution, and contains more dissolved minerals than cold water. As this hot water surfaces and cools, it can no longer hold these minerals. Because of this, deposits occur around hot springs and geysers, as seen in the photo above of this hot spring in Yellowstone National Park. These deposits form a rock called travertine and are referred to as travertine terraces, seen in this photo of a geyser, also in Yellowstone. Limestone fully dissolves in water, and so caves and caverns are commonly found in regions with limestone deposits. There is often little to no evidence of where these limestone deposits or caverns may lie on the surface. As caverns increase in size, support is lost and ground collapses to form a sinkhole. This ground often doesn't restabilize and may recollapse years later. Sinkholes are found worldwide and can swallow homes and businesses whole.
Permeability refers to how fast water can pass through rock layers in the ground. Meanwhile, porosity refers to the proportion of open spaces in the soil material itself. Porosity interacts with and is the main reason for permeability increasing or decreasing. When rocks have less porosity, they have a lower permeability, and vice versa. Soil porosity may change over time due to the water-transported sediments building up in open spaces. Often these spaces are filled with water and air as well. Rocks such as sandstone readily absorb water. However, other rocks are completely impermeable, allowing no water through. This is a karst, a landscape underlain with highly soluble rock, like limestone. On the surface, very little water is visible as the streams disappear underground into subsurface caverns. Because there is little water, there's also very little erosion, which means there are generally dry valleys. This is the use stage. Depressions are found on the valley floor as the ground slowly begins to collapse. There is a dry surface as the streams disappear through a sinkhole. As water continues to dissolve the limestone, support for the overlying rock is minimized and the cave ceilings collapse, creating several sinkholes, which will, eventually, combine to create a large depression called a uvula. This is the mature stage. When the entire cave collapses, large gorge features called polges take shape. The only remains are small hills of rock fragments known as hums. This is an experiment my group members and I did with a sponge and some rocks. This experiment shows the effects the water table has on layers of the ground. The sponge represents the water table, which may shrink or expand depending on the water in the ground. In some cases, the water table may rise to the surface, which is why flooding occurs. Lakes and ponds prove to us that the water table may never be lower than the bottom of the lake at any given time. This experiment was highly beneficial in increasing our understanding of the way permeability, porosity, and the water table interact with each other when a large amount of water is added to it all.
An aquifer is a body of permeable rock that holds groundwater, which can then be tapped into to be pumped out. And aquifers are often used by farmers in drier areas as they tap into aquifers by drilling a well and pumping the clean water to the surface for drinking or for irrigation systems on their farms. There are two main types of wells. An artesian well is when a layered permeable rock, or an aquifer, is sandwiched between the two layers of non-permeable rock. This puts the aquifer under enough pressure that if drilled into, the water will flow to the surface under its own power. An ordinary well is when another layer of permeable rock is laid on top of a saturation zone. The water from these wells needs to be pumped out as they are not under the same pressure from the non-permeable rock as an artesian well is.
Our case study relates to the effects of aquifers on our daily life. The photo here shows drilling on a construction site in Surrey. This drilling hit an aquifer, causing it to flow uncontrollably as it was encapped. Solutions included drilling other relief wells to reduce pressure, although it is simply impossible to fill it with concrete while water continues to rush out. Aquifers in BC are generally all mapped and accounted for, although certain contractors can sometimes be caught unaware. This story highlights the importance of being aware of the presence of groundwater.
Water, goddamn, water, water, okay, water, what? Water, drip, water, splash, water.